If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to discuss division algorithm for polynomials. As told in the earlier video, we have already covered exercise 3.1, 3.2 and 3.3 and polynomials introduction and the concept that is needed like zeros, coefficients, linear, cubic, quadratic polynomial. Everything is available in the playlist of the polynomials, which will be attached to this video in end card. End card is nothing but the last when you reach the end of this video, there will be a card displayed. Within that you will get to see the list of playlist of the polynomials. You can find it there. So today we are going to discuss division algorithm for polynomials. So we have discussed this division algorithm earlier also. So where have we discussed? If you have gone through my first chapter video like real numbers, we have discussed Euclid's division algorithm. It's the same thing which follows the same thing, wherein we have assumed the numbers there. Here we are going to assume the polynomials. So if I'm trying to state the algorithm, if p of x and g of x are two polynomials, then q of x and r of x are two more polynomials. Then here there exist q of x and r of x are two polynomials such that what is the division algorithm? If p of x and g of x, p of x is the dividend, g of x is the divisor, what is the algorithm? Dividend is equal to divisor into quotient plus remainder. That's the same algorithm which we have discussed, wherein in the Euclid's division algorithm we said that remainder is always less than divisor. If you are coming and watching this video for the first time, this concept, the Euclid's algorithm concept, is very clearly explained in the real numbers chapter. Please go through that as well. Alright, so now there remainder is always less than divisor. Here, since we are dealing with polynomials, the degree of remainder is always less than g of x, isn't it? And what happens? Are there any chances that r of x be 0 when the remainder is 0? Yes. When r of x is equal to 0, then what happens? We call that g of x exactly divides p of x, or q of x, the quotient, is a factor of p of x, or g of x divides p of x exactly. So this is about the division algorithm of polynomials. What is an algorithm? The step-by-step procedure that we do to achieve a process. So in division algorithm for polynomials, if we assume p of x as the dividend, g of x as the divisor, there will be a quotient and remainder which are nothing but q of x and r of x, such that dividend is equal to divisor into quotient plus remainder. When the remainder is 0, then we say that either q of x, the quotient, is a factor of p of x, or g of x divides p of x exactly. So this is the concept that is needed for us to solve the problems in exercise 3.4. So now that we understood the concept, the division algorithm, let's jump into the exercise part. No, you cannot directly jump into the exercise part. So you have to look at the examples before the exercise. First, go through the examples. Just pause this video here. Go through the examples. There are 3 to 4 examples. Just go through them. It hardly takes 5 to 10 minutes. Then unpause the video and start looking at the exercise problems. All right, so let's jump into the exercise now. I hope you guys have already gone through the examples. I have already ready with the problems listed on the board. So let's jump into the exercise part. Here in the very first question, they are asking us to divide p of x by g of x and find quotient and remainder. So p of x is given, g of x is given. How do we do it? G of x is the divisor, so x square minus x plus 1. Why did I write x square minus x plus 1? While doing the division part, we need to consider all the degrees of x. If the degrees are not given, we need to assume 0 in those. Say for suppose you have a cubic polynomial and they have given x cube minus x. Then the x square term is 0, right? So we have to consider it like x cube plus 0 minus x. And for quadratic polynomial also 2 x degrees 2 then 1, then the constant should come. So we need to make sure that the degree is in the descending order while either considering the divisor or dividend, anything. Okay, and next p of x is given as x power 4. Cube term is missing here, so I am assuming 0 minus 3x square plus 4x plus 5. Why did I assume 0 here? Because x cube term is not given. That's the reason. Now, first, how do we solve the polynomials division? This is nothing but we need to understand what is the first term in the dividend, and by multiplying with what you get the same term in here. That is what we need to check. We have x square here. In order to get x power 4, we need to multiply this x square with x power 4. So I am going to multiply this with x square. So x square into x square is x power 4. X square into x is x cube minus x cube. Now x square plus 1 is plus x square. Now you understood why I have put 0, because if you don't put 0 here, you will be substituting this x cube in place of x square. That way you will end up in mystery. Alright. So if the degree, one of the degree is missing in the polynomial, we need to assume a 0 over here. Alright. Now how do we do the subtraction here? That is the reason I have asked you guys to follow the examples. When we are doing with expressions, the signs change for division. When there is minus, when there is plus, you put minus. When there is minus, you put plus. Now, plus x power 4 and this sign becomes the sign for this. They get cancelled. What is the sign of x cube? Plus. Plus x cube. Minus 3x square minus x square is minus 4x square. I am dropping them down. 4x plus 5. Now we have x square here, but we have x cube here. In order to get x cube, what should I multiply divisor with? Plus x. Now multiply x with this. X cube minus x square plus x. This is the way we are writing. See, there is no constant term, so I left the constant place and wrote just x square. This is how you need to write, else you will end up committing mistakes. Now the signs change. X cube gets cancelled. Minus 4x square plus x square minus 3x square plus 4x minus x plus 3x plus 5. Alright. Now we have x square here, but we want minus 3x square. So we multiply it with minus 3. Minus 3x square minus x into plus minus 3 is plus 3x. Now plus 1 minus 3. Minus 3. Again for the subtraction, what happens? The signs change. Here there is a minus, so I put plus. Here plus, there is minus and plus. These two gets cancelled, minus 3x square and plus 3x square. 3x minus 3x gets cancelled. 5 plus 5 and plus 3 is going to be 8. So from here, what is the quotient q of x? Is equal to x square plus x minus 3. What is the remainder r of x? Remainder r of x is equal to 8. So that's about the second bit in first problem. So I'm going to solve the third bit in first problem. I have taken the different kind of problems and trying to solve them so that you will have a better understanding. Here if you see in g of x, we just have minus x square and 2, which can be written like this, minus x square plus 2. Now let us do the division part. So this is minus x square plus 2 is divided with x power 4 you have, and then you do not have the cube term, you do not have the square term, and then you have minus 5x plus 6. Alright, now we have x power 4 here, but we just have x square here. So I am going to multiply it with minus x square. Minus x square results in x power 4, and minus x square plus 2 is going to be 2x square. So I am going to substitute it here, and this is going to be like this. This is a cube term, right? So cube term I do not have even in the divisor, so I have substituted nothing there. So x power 4, if you want you can put a 0. Alright, and this is going to be minus 2x square minus 5x plus 6. Alright, now you have x square here, minus 2x square here, but only x square here. So what am I trying to do? I am going to multiply it with plus 2 such that it becomes minus 2x square, and plus 2 multiplied with plus 2 becomes plus 4. So again the signs gets changed, and this is minus 5x plus 6 minus 4 is 2. Alright, this is minus 5x plus 2. Now the division stops here because this is in x terms and this is in x square terms. Alright, so here the quotient, what is the quotient here? Minus x square plus 2, and the remainder r of x is equal to minus 5x plus 2. So while doing the division of polynomials, please make sure to check whether all the degrees of the polynomial are covered or not. If not, you need to place zeros like this as I shown. This is the reason why I have solved this bit, else I would have left this for your exercise. So you need to ensure that where to substitute 0, where to put x square, where to have this. Here if you see this within the divisor also you do not have a x term. So for that we haven't substituted any x term over here. When there is no term in the divisor, you have to make sure when you are multiplying divisor with quotient, whatever the degree that comes out should be substituted accordingly. When you multiply this with this, you got a x square term here, but you do not have a x square term. So I put a 0. So this is the trick that is needed while solving the polynomials. You have to make sure all the degrees are covered or not. If they are not covered, you have to ensure to put zeros in among them. Alright, so that's about first problem. Let's jump into the second problem. So here we have the second problem. Check if first polynomial is a factor of second polynomial by dividing second with the first is what they are asking us. So in order to be if the divisor is a factor of the polynomial, dividend, then what we said, then the remainder will be 0. If you remember the division algorithm, while saying it, I said when you get the remainder as 0, then that the divisor is said to be a factor. Divisor or a quotient is said to be a factor of the polynomial p of x. So here we need to do the division part, and if the remainder is equal to 0, then this is said to be a factor of this, and if not, this is not going to be a factor of this. That's what we are going to conclude. Alright, so here x cube minus 3x plus 1. Here in the divisor also we do not have the x square term. And here x power 5, no, x power 4 minus 4x cube plus x square plus 3x plus 1. Alright, here we have x cube, here x power 5. What do we multiply it with? X square. So that becomes x power 5 minus 3 into x, and this is x square minus 3x cube and plus x square. Now how does the subtraction happen? By changing signs. Minus 4 plus 3 is minus x cube, and x square minus x square gets cancelled. Now these are going to come into picture, 3x plus 1. So x cube minus 3x plus 1 we have, minus x cube plus 3x plus 1 we have. So I am going to multiply this with minus x such that it becomes minus x cube plus 3x multiplied with minus 3x multiplied with x becomes minus 3x square and minus x. Alright, now the signs going to change. This becomes minus 3x square plus 3x plus x, 4x plus 1. Now we have x cube here and x square here, so the division ends here because x cube cannot divide x square. So here the remainder is not 0. Here remainder is not equal to 0. Hence g of x, this is our p of x and this is our g of x. Hence g of x is not a factor of p of x. Alright. So here we did the division part and we did not get the remainder as 0, and hence we just substituted it like we said, remainder is not equal to 0, hence this is not a factor. Alright. So here we are solving the second bit in the second problem, wherein the divisor is x square plus 3x plus 1 and the dividend is 3x power 4 plus 5x cube minus 7x square plus 2x plus 2. X square is here, but we need 3x power 4. This we get by multiplying it with 3x square. So 3x power 4 plus 3x into 3x square is 9x cube plus x into 3x square is 3x square. Sorry, 1 into 3x square. Now the signs get changed. Cancellation. Minus 9 plus 4 is plus 5 is minus 4 and minus 10x square, and this comes down like plus 2x plus 2. Alright. Now we have x square here, but we need minus 4x cube. So I am going to multiply it with minus 4x. That will result in minus 4x cube minus 4 3 is 12 x square minus 4x. Again, the signs get changed for the division part. So this gets cancelled. Plus 12 minus 10 is 2x square plus 4 plus 2 is 6x plus 2. We have x square here, but we need 2x square here. So let me multiply it with 2. That becomes 2x square plus 6x plus 2. For the subtraction, as the signs change, the remainder is 0. What is it when the remainder is 0? When the remainder is 0, remainder is equal to 0. While explaining the concept, what did I say? G of x becomes the factor of p of x when the remainder is 0. Hence, if we assume this as p of x and this as g of x, hence g of x is a factor of p of x. Alright, that is about problem number 2. Let's jump into problem number 3. They are asking us to obtain all other zeros of this polynomial if two of its zeros are root 5 by 3 and minus 2 root 5 by 3. So if I am to put it in terms of x, this is going to be x minus root 5 by 3, and this is going to be x plus root 5 by 3 is equal to 0, which is nothing but x square minus 5 by 3 is equal to 0, which is nothing but 3x square minus 5 is equal to 0. So this says that 3x square minus 5 is one of its 0. We are to figure out the other things. So what do we need to do? We need to do the division part, like 3x square minus 5 divides 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. So first is 3x square, but we have 3x power 4 here. So we need to multiply it with x square. So 3x square is 3x power 4. Next, minus 5 into x square is minus 5x square. Remember, you need to put the values under the same degree at once. Alright. So this is going to be the signs change. This becomes 6x cube plus 5x square minus 2x square is plus 3x square. They come down, minus 10x minus 5. Now here we have 6x cube and 3x square. So what do we multiply it with? Plus 2x. So that becomes 2 3s are 6. X cube minus 5 multiplied with 2x is minus 10x. As the signs change, the values gets cancelled and you get 3x square minus 5. 3x square minus 5 is nothing but 1s. That gives 3x square minus 5, and as the signs change, they gets cancelled and the remainder is 0. Now they are asking us to figure out the other zeros. Other zeros are nothing but x square plus 2x plus 1. How do we figure out the other zeros? X square plus 2x plus 1 is equal to 0, which is nothing but directly I can write it as x square plus x plus 1 is equal to 0. X into x plus 1 plus 1 into x plus 1 is equal to 0. So x is equal to minus 1 comma minus 1 are the rest of the zeros. This is a power 4 polynomial. So it will have at most 4 zeros. 2 of the zeros are already given, which resulted in a polynomial. We used it to divide the polynomial and we attained a quotient where the remainder became 0. This quotient we have used to, we did the factorization and got the rest of the zeros. Alright, so that is about problem number 3. Let's jump into problem number 4. So here I am ready with the fourth problem already written on the board. So let's go through it. On dividing this polynomial by a polynomial g of x, quotient and remainder are given to us. We need to figure out g of x. Okay, so even before trying to figure out what is the rule that we have learned for a polynomial p of x, when it is divided with g of x, there exists a quotient q of x and a remainder such that this is the division algorithm of polynomials. This is what from division algorithm of polynomials. Now, what is p of x? P of x is given as x cube minus 3x square plus x plus 2 is equal to g of x is, that is what we need to figure out. And quotient and remainder are given. What is the quotient? X minus 2 plus remainder is minus 2x plus 4. So I am going to send this to other side. That way it becomes x cube minus 3x square plus x plus 2 plus 2x minus 4 is equal to g of x multiplied with x minus 2. Alright. Now let's do the simplification part. X cube minus 3x square plus x and plus 2x becomes plus 3x plus 2 and minus 4 is minus 2 is equal to g of x multiplied with x minus 2. Now this multiplication x minus 2, I am going to send it the other side such that g of x becomes x cube minus 3x square plus 3x minus 2 by x minus 2. What is it? The division. What are we dealing with? Divisions. So now we need to divide this with x minus 2. That way we get g of x. So let's do that. So x minus 2 is going to divide x cube minus 3x square plus 3x minus 2. Alright, here we have x, but we need x cube. What do we multiply it with? X square. So that becomes x cube minus 2x square, isn't it? Now the signs get changed. X cube gets cancelled. Minus 3x square plus 2x square is minus x square plus 3x minus 2. Now we have x in the divisor, but we need x square here, minus x square. So let us multiply it with minus x. So that becomes minus x square. Minus x multiplied with minus 2 is plus 2x. That way, as the signs change, x square gets cancelled. 3x minus 2x is x minus 2. X minus 2 we have here, x minus 2 we have here. How do we get it? By multiplying it with 1. As the signs change, plus x minus x and plus 2 minus 2 gets cancelled and the remainder is 0. So now what is g of x? Nothing but the quotient. The quotient is equal to, so what is the result of this division? G of x, whatever we have done is nothing but x square minus x plus 1. That implies that g of x is equal to x square minus x plus 1. So that's about problem number 4. Let's jump into problem number 5. So here the last problem of the exercise, which is 5th problem, they are asking us to give examples of p of x, g of x, q of x, r of x which satisfy division algorithm and whatever the condition they gave. So we have division algorithm, right? From division algorithm, in the second bit I am solving from division algorithm. What do we have? What does it say? P of x is equal to g of x into q of x plus r of x. That's what it says, right? Now what are they saying? Degree of q of x and r of x is equal. So if let us try to assume if degree of r of x is equal to 0. Let us assume if degree of r of x is 0, then what happens? It will be only constant. When degree of r of x is equal to 0, q of x is also equal to degree of r of x. What happens? This becomes 0. P of x becomes 0. So we cannot assume that. So let us assume this degree of r x as 1. Then what happens? Degree of q of x is equal to 1. And g of x. So g of x will always be a degree more than 1 of the remainder, isn't it? R of x, what do we said? Remainder is always a degree less than g of x. So this should be always a degree more than this. So this becomes degree of 2. Now what happens to degree of p of x? When we are dividing it with the polynomial 2, it will also be a degree above from this. So this becomes degree 3. So now since this has a degree of 1, the quotient, let us assume the linear polynomial of x plus 1. Alright. So what happens now? P of x will be x plus 1 whole cube is equal to what happens? G of x is nothing but x plus 1 whole square multiplied with x plus 1. This is satisfied. This is x plus 1 whole cube is equal to x plus 1 whole square into x plus 1. What did I do in the above algorithm? I just put a linear polynomial. Now what happens? Here the degree of q of x is 1. But he said that within the condition degree of r of x also is 1. So here we need to add a remainder of x plus 1. Now what happens? This equation will break. So what do we need to do? We need to add x plus 1 on both the sides, isn't it? Else x plus 1 whole cube is equal to x plus 1 whole square into x plus 1. That is satisfied. But here, since r of x degree is equal to q of x, we have to substitute r of x as x plus 1. But this will break this equation. So I have added x plus 1 on both sides. Now let us expand the forms. X cube plus 1 plus 3x square plus 3x plus x plus 1 is equal to x plus 1 whole square is x square plus 2x plus 1 into x plus 1 plus x plus 1. Alright. Now this becomes x cube plus 3x square plus 4x plus 2. And this is x square plus 2x plus 1 is g of x. Q of x is x plus 1. Alright. What is this? This is p of x. What is this? G of x. What is this? Q of x. And this is r of x. So here if you try to match this solution with your textbook answer, it may not be same as that one, but here since they just asked us to give the example, we took an example such that it is satisfying the condition that they are giving. It may not, you can give n number of examples. If your teacher gives you an example which is exactly in sync with the textbook, you can go through it, but this is the way you need to solve it. Alright, so let's jump into the third bit. Third bit is nothing but degree of r of x is equal to 0. Here also from the division algorithm, what I am going to do is g of x into q of x plus r of x. P of x is going to be x plus 1. Again, the same thing I am trying to do. Here x plus 1 whole square and x plus 1. Since the degree of r of x is 0, I am assuming the constant to be 0. This is exactly solving the equation. Now that here r of x is equal to 0, q of x is equal to x plus 1, g of x is equal to x plus 1 whole square, which is nothing but x square plus 2x plus 1, and p of x is equal to x plus 1 whole cube equal to x cube plus 3x square plus 3x plus 1. Alright, these statements and all you can copy from whatever your teacher says. So this is how you need to solve the problems in this bit. You need to take the division algorithm, assume a value to each of the polynomials p of x, g of x, q of x, the degree you have to define, and then solve the problems accordingly. So congratulations, we have successfully, Anantha Lakshmi Academy has successfully completed the third chapter of 10th class mathematics, which is polynomials. Next, I am going to start one more important chapter of mathematics, which is statistics. So I'll be starting on statistics in the next session, in the next video. Till then, if you are understanding this, you think that the content is worth enough, please do like, share and subscribe to Anantha Lakshmi Academy. Also, please do share it with your 10th class friends or any relatives who are studying 10th class. So till then, keep watching Anantha Lakshmi Academy. Wait and watch till the next video comes on the chapter statistics. Thank you for watching.